All right, I am here to talk about a tool I wrote a little earlier this year and just released called Icebreaker. It's a Python tool for getting a foothold on Active Directory networks. My name is Dan McInerney. I'm a senior pen tester and researcher at Coalfire. Coalfire did give me quite a bit of time paid to work on this, which is why I'm giving them a shout out. About half of it was my own time, half was about Coalfire time. I've been with them for a few years, and that's my GitHub, Dan McInerney. Pretty simple. It's one of the top 100 most popular Python accounts in the world. Just going to give myself a little pat on the back there. This is the overview of the tool. So in order to set it up, all you do is git clone it, and then you cd into the directory and run the setup script. After you run the setup script, you do pipenv, which is a new Python packaging tool, which makes it easier to use virtual environments. That way it doesn't mess up your system quite so much. And then pipenv shell, and then you can actually run the tool. One issue that Icebreaker has, if I'm going to start off with a disadvantage, is the installation process takes a while. So if you're on a low resource machine, then it can take, low resource with bad internet connection, you're looking at like half an hour for the install or more. So I'm working on getting this Dockerized. If anybody wants to help me with that, I don't know anything about Docker, but it would sure make this a lot easier to install. The script is largely just glue between already known techniques and attacks. It's not brand new research or attacks. It just makes the whole process of getting Active Directory plain text passwords a lot easier. This is sort of the base. I'm not going to do a lot of Python code teaching here, but this is sort of what it's based on. Subprocess is a library for Python that lets you make system calls. Now, I'm sure if any Pythonistas are in here, you're probably looking at that and thinking, that's not all that impressive. You might as well just use a bash script if you're just calling system calls. But there's a lot of complexities I added into this that make it worthwhile to do it in Python, namely asynchronicity. So I can do concurrent programming. I can test usernames concurrently in parallel. So there's a bunch of reasons for why I wrote this in Python, not just a silly little bash script. But this is the basis of how it works. It's calling other tools, and then I also have the whole thing packaged up so all those tools come with Icebreaker. You don't have to go out and manually git clone responder and git clone rid enum and all the tools that it uses. Everything just comes already built in, including the password cracker. So it comes with John the Ripper. It will automatically compile that through the setup script. That way, it's just nice and simple. The installation is not anything farther than run the setup script, pipenv install, and pipenv shell. So it does 5 different network attacks. The scenario that you want to use Icebreaker for is when you are on an internal network that's Active Directory, but you don't have any passwords. So like you're just a Kali Linux box on an internal network, but you have no access to the Active Directory environment whatsoever. This will get you access to the Active Directory environment. It does 5 different attacks to get plain text credentials and NTLM hashes, which are the more or less the equivalent of passwords. The first attack is the nice, simple, and fast RID cycling into reverse brute force. So reverse brute force is when you take a short list of short list of passwords and a long list of names, and you just test that short list of passwords against those names. The reason we're doing that and not an actual brute force is because brute forces tend to lock systems out. So we are doing just 2 passwords per username. The way it finds usernames to actually brute force is A, it looks for null sessions, null SMB sessions, and B, it will, if you give it like a domain name, it'll go out to that domain name, scrape email addresses, and then use the first half of the email address as the username, because that's pretty common in corporate environments. So RID cycling is pretty cool. It hunts for null sessions, first of all. Null SMB sessions are when you can connect to a remote Windows computer and query it for information and stuff through the SMB protocol. You can query it for usernames. What you do is something called RID cycling. So every account on the computer will have a SID, and a SID is I think it's a security identifier or something. And it's a big long string of numbers and letters, and at the very end it'll say dash and then a number. And the first number that it starts at is 500. That's the built-in local admin. So the SID is this long string, dash 500, that's local admin. The users will start at 1,000. So it'll be a big long number, dash 1,000 will be a user. And you can ask through null sessions, what is the username of this person with the RID is that final number. The SID is the full thing. RID is the final number. what's the username of that final RID? And you can just cycle through all the RIDs because you know they start at 1,000. So you can just start at 1,000 and go up to like 50,000 and get everyone's usernames. That's how it finds usernames. Then we asynchronously test all of these usernames using 2 passwords. And these are the most effective 2 passwords on AD environments that I have ever seen, and I've been working in AD environments for years. It's password with an @ and a 0, and it's season and year, like spring 2018. So this tool has built-in capabilities to detect what season it is, and then it'll automatically look for password usernames that allow the password spring 2018 for right now. Last season it would say winter 2018. So it's not statically spring 2018. It's whatever the actual season is how this will work. You can also use a custom password list. I like just sticking to the first 2. Those first 2 passwords are extremely effective. If you can get a long username list, man, I'm going to say like, if you can get maybe 30 to 50 users, there's an excellent chance that one of those 2 passwords is going to pop that account, which is fantastic. And then you have a plain text cred for a username. And then you can, pump those creds into Bloodhound and work your way through if you want to do that. It asynchronously tests it using, I think, 10 different jobs at once. So it's pretty fast. It does that attack first because that attack is generally pretty fast. This is what it looks like in use. You can see it'll say we're doing attack 1. We're checking for null sessions. It found a null session on 10.2.0.99, which then gives it the domain name. It also gives it the usernames, and it brute forces them pretty quickly. The second attack it does to get plain text, to get passwords, is the SCF attack. This is one that a lot of people actually don't seem to know. This is probably the most, what's the word? I don't know, rarest known attack that it uses, but it's really simple. Windows has a strange file type called SCF. It stands for Shell Command File. And I keep wanting to say SCF file, but that's like saying ATM machine. The SCF is a very short file that you can tell it to find an icon somewhere on the network. Normally, these files are used for things like opening up Explorer, just simple little things like that. Open Explorer to a certain folder, like silly little things. I'm not even sure why this exists. But you can tell it to have an icon inside the file. And if you tell it to have that icon hosted on your own attacking machine, whenever someone opens a file share that has this SCF file on it, their SMB hash is being sent to you, which I don't get it. It's absolutely ridiculous, but it is the way Microsoft did it. So Microsoft patched this only for Windows 10. It is not patched for Windows 8 or 7 or any of these other ones. So what Icebreaker does, after it does a reverse brute force, it finds usernames, does a reverse brute force, we'll say it doesn't find anything. It moves on to attack 2. Attack 2, it's going to find all anonymously readable and writable network shares. Actually just writable, not necessarily readable, but all anonymously writable network shares. And it will upload an SCF file. An SCF. This is what it looks like. It just says shell, command 2, and then the icon file is where it actually matters. That's the attacker machine. That's my machine, the Icebreaker machine. So we'll tell it, so we'll upload that file to all the file shares. Anytime anyone opens up that file share, they don't even have to click this link. They don't have to click on this file. They don't have to even know this file exists. They just need to open the file share where this thing is held, and you have their SMB hash. So Icebreaker, you can't actually pass a net NTLM hash, which is what you're going to get from this. You can crack it, though. So Icebreaker automatically does password cracking. Anytime it gets any kind of net NTLM hash, it'll automatically try and crack it using a custom word list. And that custom word list comes from the GitHub account seclists. I took every password in seclists, and then I got rid of everything that was under 7 characters, over 32 characters, all lowercase, all uppercase, all numbers. All of that's gone. So now the password list is down to about 1 million passwords, and they're all default AD compliant. We don't want to be testing passwords like 1, 2, 3, 4, 5, 6. That's not valid on default AD environments. So we have this nice, short, concise password list that only works, that's very specific to Active Directory environments, and that makes password cracking much, much faster. This is what it looks like in action. It'll just say, writable share found, successfully wrote it. It'll make sure that the file is uploaded by then querying the file share to see if the file is there. And it'll say, all right, great, everything worked great. Now we're just going to wait for someone to open that file share. Attack number 3. Again, the first 2 attacks are extremely fast. Just takes like a minute or 2. The SCF one doesn't even take a minute. Attack number 3, it'll linger a little bit. This is where it's going to be doing Responder. Responder is a really cool poisoning tool that Laurent Gaffy wrote. I don't know if I'm saying that right, but it sounds French, so I'm going to pronounce it like that. He wrote it to do poisoning for multicast and broadcast-based protocols. Multicast and broadcast protocols are protocols that send out messages to either the whole subnet or just some of the subnet, but it sends out messages kind of just like blown out there on the network for whoever wants to receive them. All of these protocols, LLMNR, NBTNS, and MDNS, are all basically DNS. They attach an IP address to a host name, which means you can poison them just like DNS. You can be like, you know, their computer spits out a request for, hey, who's at, you know, / Google, you know, who's got the computer named Google? You can be like, I got Google. And they'll be like, oh, great, well, here's my net NTLM hash. And you're like, okay, thanks a lot. The responder is used in the background of Icebreaker to poison these protocols. And because all of these protocols implicitly trust the responses, piece of cake to poison them. What you get out of responder are net NTLM version 2 hashes. Again, you do not get hashes that you can pass. You can't just take the net NTLM hash and then use that in place of a password. But that's okay because Icebreaker will automatically crack it. This is kind of how LLMNR and NBTNS poisoning works. It's pretty simple. You're basically just man in the middle in them. Computer sends out a packet. You respond to it faster than anybody else. And this is what it looks like in action. So you can see the NTLM password is that long, long string of numbers and letters there. It says Bob Lab. Bob is the username, Lab is the domain. And you can, Icebreaker will automatically crack that. You can also skip cracking if you don't want your resources to be used on that. You just use the -S flag to skip any of these attacks. So you can like just use the SCF attack if you wanted to, or just the NTLM relay. But it'll try and crack it, and you'll notice here it's using John the Ripper, and it found the password, which was, of course, P@SSW0RD, one of the most common ones. The fourth attack is the one that I think is the most effective. This is the one where Icebreaker, it lingers on attack 3 for 10 minutes by default. It'll just run responder and wait 10 minutes to capture some hashes. If nothing is found or 10 minutes is up, it'll move on to attack 4, which is NTLM relay. NTLM relay is an awesome, awesome attack. It works in, I would say, the majority of Windows networks for getting passwords and command execution as local administrator, which is really what you're looking for. This is a man-in-the-middle attack against SMB connections. Two computers are connecting over SMB, and they're sharing files back and forth, or they're just pulling information about the system. SMB is a file sharing protocol. It's pretty simple. And so we're going to be using NTLM Relay X from Impacket to be doing the NTLM relaying. So what we are going to be doing is essentially running responder and NTLMX at the same time. So we're poisoning the SMB protocol. So when a computer calls out, hey, where is Exchange? You'll be like, it'll go connect to the actual Exchange server, but you are going to be right in the middle of that connection. So you can hijack that connection. After you hijack the connection, you can get the net NTLM version 2 password credentials, password hash, and then you can just relay that to a machine. So net NTLM version 2 hashes, you can't pass, but you can relay. So you can take the hash that one computer sent validly to another computer, and then you pass that hash to that computer and tell it to run your commands. There's a few caveats with this one, though. Number one, SMB version 1 has to be enabled. I believe by default now Windows 10 no longer has that enabled.
No,
it's still enabled.
Yeah, I've reinstalled the machine last week. It's still
Oh, okay. Fantastic. Thank you, Microsoft. You have to have SMB version 1 enabled, and you have to have SMB signing disabled. I believe that, I'm not sure if Windows 10 now has that enabled by default too, but it hasn't been enabled for the last several versions of Windows. SMB signing actually slows down the network connection by about 15%. So there's a valid reason why you would want to disable it. So it's disabled all the time, especially in older systems. So once you have those two caveats met, then NTLM relay is just going to go ham all over the network. So an NTLM hash is the top hash. Net NTLM version 2 is the bottom hash. You'll see net NTLM version 2 is what they use for usually network services that are communicating with servers. NTLM hashes are what's actually stored on the computer in LSASS. So those are the hashes that you can just pass like a password. And the net NTLM hash, you cannot pass that. You have to relay that one. You'll notice the net NTLM hash also includes the username and domain. That is part of the hash. So if you're trying to crack these in Hashcat yourself, you need to include admin : lab. You can't just have the actual hash data there. And this is kind of what a net NTLM hash looks like. It'll start with the username, and then it'll go to the domain, and then it'll go to the LM hash, which is disabled pretty much 100% of the time. You'll never really get a valid LM hash. And then you'll get the actual NTLM hash. It's a challenge response protocol, which is why you can't pass it. You can only relay it. So there was a bit of confusion for the last few years about exactly what passing the hash accounts you can use. And it turns out, as of today, you can pass the hash with the local built-in administrator account, the RID 500. You cannot pass the hash with the other administrators on the box. That was a Microsoft patch. They called it the pass the hash patch, but it wasn't. I mean, you can still pass the hash. You just need to use the RID 500. So Microsoft, I don't know, blowing smoke up. You can, however, pass the hash with other administrator accounts if you set a registry key. That registry key is in local machine filter administrator token. So if you have admin access to a box, you can just set that key to be 1. And now you can pass the hash for everybody, which is pretty cool. Yeah, if you want to read more about this, Harmjoy has a blog that is extremely good. There's a little link there. I doubt you can read it, but I'll post the slides publicly so you can do that later if you want to. But he goes into exceptional detail about the pass the hash patch that Microsoft put out and why it's just a piece of crap. This is how NTLM relay works. So you've got one computer negotiating authentication with another computer. You are in the middle of that, so you are going to copy the server challenge, pass it back. The server challenge is going to send it to you. You pass that over to the actual valid, to the